Section 2.1, first derivative for min and max. Let's say we start by given f of x is given, let's say a function and a variable x. If the derivative of this function is bigger than 0, then f is increasing. So the graph goes up from left to right. So I'm going to use this arrow to represent increasing. F prime of x, if it's less than 0, then f is decreasing. It goes down. And to apply this, let's take a function f of x, 1/3 x cubed minus x plus 2/3. And we need to check when is it increasing, when is it decreasing. We need to find f prime of x, the derivative of the function. I'll keep the 1/3 down. 3 down, x squared minus 1 plus 0. So f prime of x equals x squared minus 1, which can be factored as x minus 1, x plus 1. Now to study when is this bigger than 0, when is it less than 0, we use the number line. Number line is the easiest way to check about the signs. We have a -1 and a +1 from these factors. Then we run some testing points, say x equals 2, for example. Substitute into this circle part. Will we get a positive or negative value? It's going to be positive. If you pick x equals 0 in here, that's between -1 and 1. We will be getting -1 times 1, that's a negative. If you pick x equals -2, that's going to be positive. So the question is, when is f prime of x bigger than 0? Well, it's bigger than 0, where is the plus sign on the number line? It's from -infinity to -1. Also 1 to infinity. And to combine them, we use the union sign. So this is called union. This means f prime of x bigger than 0 over this. That's where f is increasing. Where f is increasing. F is decreasing when f prime of x is less than 0. That's when x between -1 and 1. That's decreasing. And graphically, what it means, if I redraw the line that I just constructed, plus, minus, plus. So the graph would look like it's increasing, then after this point is decreasing, then increasing at that point. That's how the graph would look like. Now what happened if at these 2 points, so when I set the derivative f of f prime of x equals 0, that means x minus 1 and x plus 1, those are equal to 0. To solve this kind of equations, we set x minus 1 is 0 or x plus 1 is 0. So x equals 1 or x equals -1. These two numbers that we got are called critical numbers. These are critical values or numbers. So how do we find the critical numbers? Critical numbers are found by setting y prime, the first derivative, 0 or does not exist. Or does not exist. Notice usually the graph is not drawn perfectly here, but say it's somewhere there. So it's increasing like this and down, say here. This would look like the graph of the function. Now, if we take a random graph for any function, say something like this, this is f. At these points, this point here, call it like at x equals a. At this point, at b. At this point, call it C. At this point, D. At this point, E. At these points, we can draw vertical, horizontal tangent lines. As you can see, that's a tangent line, horizontal tangent lines. So y prime for this graph would equal to 0 at x equals a, b, c, d, and e. Okay. If I want to modify the graph a little bit, let's make it a V shape. A V shape. Call this F. So y prime equals 0. That's when y prime gives us the slope of the tangent line. That's when it's a horizontal tangent line. So at the points A, B, C, D, and E, there's a horizontal tangent line. And at point F, that's when y prime does not exist at x equals f. So all these numbers a through f are critical numbers. All are critical numbers. So these points that we just found are called, so we say the above points are called relative min / max. How do we find them if it's not given graphically? So let's say someone asks you, find any relative or local. We call it local. Extrema. Extrema means min and max. So instead of saying min and max, we say extrema of this function y equals x cubed minus x squared minus x plus 2. To do that, we need to find the derivative and see when is it 0 or does not exist. So the derivative here is 3x squared minus 2x minus 1. We can factor this one out as 3x and x minus 1 plus 1, and you can test it. It should work. When does that equal to 0? Equals to 0 when the 3x plus 1 is 0 or x minus 1 is 0. 3x equals negative 1, so x is negative 1/3. Here x equals 1. So we have two values. Those values are called the critical numbers. To know if it's a minimum or maximum at these points, we use the number line. We have negative 1/3 and 1. If you substitute x equals 2 into this circled part, that will give us positive, and then negative. If you pick any point, let's say 0 or negative 1, that would be positive. So the function is increasing, then decreasing, then increasing. So at this point, there's a minimum. At that point, there's a maximum. So we say f has a relative maximum at x equals negative 1/3. F has a relative min at x equals 1. Another example, f of x is 11 minus x cubed. What is f prime? Negative 3x squared. When is that equal to 0? This equals to 0 when negative 3x squared is 0. Divide by negative 3, so x must be 0. Put that on the number line, 0. If I pick a point here, say x equals 1, substitute always in the derivative, that would be negative value. If you substitute negative 1, that will give us negative 3 times negative 1 squared, negative 3 times 1, negative 3, also negative. So it's always going down. In this case, no relative min or max the function has. How about another one? y equals, let's call it h of x, x to the fourth minus 8 over 3x cubed. Then find the relative min and max, or relative extrema. How do you do that? We find y prime, which is 4x cubed minus 8 over 3x squared. When is that equals 0? Let's see, 4x cubed minus 8x squared equals 0. Let's divide by 4. X cubed minus 2x squared is 0. We can factor x squared out. That will leave x minus 2. Now, in order for this to be 0, x squared must be 0, or x minus 2 is 0. So x is 0 or x is 2. Now we pick a value. Remember, that's y prime. We're going to substitute here. Let's say I'm going to pick x equals 3. If you substitute into the circle part to see if y prime positive or negative, that's going to give us positive. If you pick x equals 1, that will give us negative. If you pick x equals negative 1, see if you substitute it in step by step. That gives us 4 times negative 1, 8 times positive 1, negative 4 minus 8. It's a negative 12, so that's a negative. So it's going down, and then goes up. So what does that tell us? The first thing, I see that the graph is increasing, if we need to get more details, over 2 to infinity, decreasing over negative infinity to 2 all the way. We have critical numbers. X equals 0 and 2. There's a relative min, as you can see, relative min at x equals 2. X equals 2. From x equals 2, if I substitute into the function y equals the given function, for x to the fourth minus 8 thirds x cubed, y is 2 to the fourth minus 8 over 3, 2 to the third, 16 minus 64 over 3. Over 3 multiplied by 3 and 3, 48 minus 64, negative 16 over 3. So there's 2 comma negative 16 over 3. That's the point, the actual point, where the graph is going to reach a minimum value. Now, can we graph it using this information? Yes, we can. X, Y. We had a 2. So this one here is about negative 5 point something. So it's a 2 comma 1, 2, 3, 4, 5 something. Say here. There's a relative min at this one. Relative min. If you set x equals 0, y 0, the graph must go through 0, 0. Those we call the intercepts. And remember, it says it's decreasing from negative infinity to 2. So it's gonna come from somewhere up there, goes through this, and then after 2 it's increasing. And you can test that by picking more points. Let's say, if you choose x equals negative 1, y would give us 11 over 3, which is about 3.6. So negative 1 and 3.6, say here. If you pick x equals 3 and substitute into the original function, you will get 9. So 1, see, we need to make this skinnier. 3 and 9, say here. And so on and so forth. So this is the sketch, just a sketch, not a perfect graph, just a sketch. So we can do, or take another example. Y equals the cubic root of x minus 1. We can recall this property from radicals. the nth root of x to the m is x to the m over n. So what we can do, we can rewrite this as x minus 1 to the 1/3. Then what is y prime? 1/3 x minus 1 to the 1/3 minus 1. 1/3 x minus 1 to the negative 2/3, which we should write it, bring it down, no negative exponents, like so. So to find the relative min and max or critical numbers, we need to set that y equals 0 or does not exist. Y equals 0 doesn't give us anything, because if you set this equals 0, you get nothing. If you cross multiply, you get 1 equals 0, it doesn't work. But it does not exist when the denominator is 0. So it means when x minus 1 is 0, means when x is 1. So this is the only critical number we have. Critical number. So we can put that on the number line to check or to study its sign. 1 goes here. If I pick a positive value, let's say x equals 2, and put it in here into the original function, it will give us a positive. If you take x equals 0 in the original function, also this will be positive. So the graph will be always increasing, always increasing. Now to graph it using this piece of information, we try to create a chart here. When I choose x equals 1, substitute into the original function, you get 0. If you take x equals 0, y would be the cubic root of 0 minus 1. The cubic root of negative 1 is negative 1. So 0, negative 1. If you take x equals 2, y would be the cubic root of 2 minus 1, which is 1. 2, 1. So it's going to go down this way. That's the graph. And remember, it's increasing from left to right. Now, another example about relative min and max. We can draw a graph or sketch a graph for f, which has a negative derivative over negative infinity to 1 and positive derivative over 1 to infinity. So negative derivative, what does that mean? Negative derivative means the graph is decreasing. Positive derivative means the graph is increasing above 1. So you can pick any point here around on the top of 1, and it's increasing after 1 and decreasing before 1. That could be a sketch. You might lift it up or down a little bit, it's fine, but it will all mean the same thing. And the last thing to explain is called first derivative test, which we kind of like used it earlier in an indirect way. First derivative test. Assume f is continuous. Assume f is a continuous function with only one critical number c. Then, first thing, if f prime changes sign from positive to negative, then there's a relative maximum at x equals c. And I'll explain that on the graph, what it means. If f prime changes sign from negative to positive, then f has a relative min at x equals c. So if you want to see it on the graph, what it means, let's say this is c plus and minus. So it's going up, going down. So if it changes from positive to negative, there's a max here. As it goes up then down, so there's a relative max. Same way for the next case, if there's a minus and plus c, so if it changes sign from negative to positive, there's a relative min at x equals c.